Starting to replace the 232 microfarad power capacitors. I'm going to be replacing them with these. Down here, I'm going to disconnect each to put them on the new ones. Found this 4 watt 1600 1.6, that is kilo ohm resistors blown. Also found the lamps, the two pilot lamps, they were blown too. So it's a good beginning here. So now the blown resistor is replaced with these two 10 watt resistors in series to make 1.6K ohms. That resistor was tied from here to the cap. That cap was moved to here. That's your red wire for the resistor. Use the second tie point was not used, so I used it to tie the resistor to the cap. And this green was also tied to the same cap. Green from the transformer is now tied to this cap like it was before. Here's a cool device I have that tests the leakage of these old capacitors. This one here is the 2 capacitor power 32 microfarads at 350 volts. It says 350 volts max surge 425. This device here will test the leakage of these old capacitors and tell you how bad they are if they're passing any DC current. Let's test this one. I've tested it already before I've started this, and it's bad. I'm testing one leg of that disconnected capacitor. What we're doing here is we're putting in 100 volts DC through this capacitor with this leakage, the bottom. And when I put it into test mode, it's going to put 100 volts DC through that capacitor, and this eye tube will, when it closes, will show us that it's charging. So here we go. So that's charging the capacitor now, and it's very slowly coming up to full capacitance. It was a lot slower when I previously did this. So what this is effectively doing is it's reforming the cap. I wouldn't put this into service. It's a bad capacitor. It's old, and it needs to be replaced. When it's leaking DC current like this, it's going to draw a lot of current on your transformer and possibly hurt it, damage it over time. Let's bring up the current. Let's the voltage to closer to the duty voltage, which is what, 350. So we're going to step up to what does that say? 150, 200, 250, 300, and that's as high as I'll need to go. See what this does for leakage. So there we have 150 volts. That's leaking badly. I don't need to test anymore. This is a bad cap. I'm just going to get rid of it. Or I'll leave it in there. It's the original. It's just going to be replaced by these 2 caps right here. And it'll be good for a very long time. All the electrolytics are replaced. I beefed up the ground on the pickup here with the chassis because mechanically this ground may not last very long. The ground is in the middle here. shares ground with each power capacitor. This audio cap over here was replaced. This was a 50 micro 25 volt replaced with a 50 micro 50 volt. And there was a 2 microfarad over here underneath the tone pot there. So that's all the electrolytics replaced. And these paper wax caps are going to be replaced eventually, but we can test the unit before we replace those. It's just going to affect the sound. I flipped the unit back over, and we're going to be replacing this paper cap on top of the audio transformer just to get that out of the way before we test it for the first time. Okay, here we go. First time firing up the Pi Cambridge after replacing the electrolytics. This will be the first time firing it up on 220 volts. What we've got going on here to do this is we've got an isolation transformer here, which is plugged into the mains. Turn that on. That's plugged into the variable transformer here, which we will ramp up the voltage from down low up to 110 in this case. From there we're going to go over to the current limiter. What this does is it sends the current through these light bulbs so that if it gets really bright, we'll see that it's drawing a lot of current, which is bad. Turn this on. We're not there yet. I'm still firing everything up. As Alex Skins would say, fire it up, fire it up, fire it up. And as Arch would say, daily, daily. So here we go. This is going to test the current limiter. We're going to just short that up. And those lights are lit up. Let's turn this off. Alright. That means we're current limiting at 30, it says 32 volts down there. And then from there, we're going to be stepping up the voltage to what the radio wants, which will be about 220, 230 volts. So we'll turn that on. The radio's not on yet. I'm just setting this up still. We've got a fluke meter here. We'll see what we've got. Read for the AC voltage. I've got the terminals in the plug here. Gotta just get them sitting in there just right so I can actually read the voltage. Yeah. Oh, I gotta turn the power strip on. Alright, the radio is off. Power strip is on. Let's get a reading on the AC voltage through the step-up transformer. That's the wrong setting, that's the problem there. Alright. I'll be back. Okay. Here we go. 70 volts from 33. I'm going to turn the radio on for the first time. Turn the volume all the way up. Take a while to warm up. Look at our current limiter. Current limiter says we're good, nothing going on there. Not really drawing anything. We're at 63 volts. Transformer wants more, I guess. So we'll bring this up. Bring it up to 120 or so. Current limiter says nothing's being drawn. Alright, lamps are on. Those are 6.3 volt lamps. We're looking for the heaters and the tubes, the valves. I don't see anything. Alright, give it some more voltage. Let's bring it up to about 170. I think I hear something. I hear a hum. I hear a hum from the speaker. Just a hum. Do I see? Yep, I see some lights on the tubes. Alright, maybe it just wants... I took the antenna off because it was in the way for working on it upside down. Should be able to hear. What do I have this set on? Set on medium wave, which is our AM band. There's definitely a hum. Volume. Volume is all the way up. Let's do some tuning on this. See if we hear anything. It should be warm up by now. I see some... There's definitely some current going through this now. Not a lot of current. But we're running at 170 volts. Let's bring her all the way up to where she wants it. I'm going to go to 220, 230. Yeah, I'll do 230. Between 220 and 240 is good. Tubes are heated. I don't hear anything. I hear nothing on the medium wave. So we replaced that power resistor, which probably hasn't been running since that blew out back in England. Not hearing anything on the medium wave. That's bad. It's very low volume then. I mean, the volume's all the way up. All the way up. I have a hum. Here's some crackling. Let's play with these things. Tubes. Yeah, nothing. Alright, you know, probably gonna have to replace all those wax capacitors. It's probably killing it. It's probably just drawing everything down to nothing. I don't hear anything. We're at 225. Some pretty good current being pulled right there. There's good current being pulled. It's gone down in voltage a little bit, so it's pulling more power than it was when it was cold, so back to 230. Oh, that's all the way up. Alright. I hear some crackling. I'm going to give this thing full power off the current limiter, see what happens. I'm going to bring it down below. And then we're going to flip the switch. Take it off the current limiter. We're at 223 here, give it full power. No, 230. 230. Yeah, the lights are about right. Hear crackling. No radio frequencies being received. Nothing. Alright, I'm going to have to replace the wax capacitors. See where that brings us. You know, I should test these tubes too. I haven't. Got to check the. Make sure they're not loose or making good contact. Got to clean that up. All right, it'll be a part 2 to this. We'll try to get this thing. Get the audio up at least. All right, look at this. Pulled out one of the valves. There's a lot of corrosion on there. A lot of oxidation. Try to get a focus on this. Look at all that. It's bad. It's just a different type of metal, I guess. Why would it have gotten oxidated? I don't know. Heat? Definitely old. We're talking 1950. Yeah, that's bad. Alright, I'm going to have to figure out how to clean that off really well. Make sure these sockets, they look alright. It's mostly the metal on these pins. Definitely different one I'm used to seeing. I like the little retainers that they put in these. We don't have those on our radios that I've seen. Well, they do for the mobile units. This is not a mobile unit. This is a desk unit. But they still put the lockers. He's locking, and they're like radio shielding, locking. The American stuff I'm used to seeing is bigger. We call these tubes. What's this? This is a newish tube. But you gotta be careful not to. They're pretty tough, but definitely gotta coax it out of there. This is what we call the Loctal type. It's keyed. It's keyed on that ridge. The ridge on the center pin keeps it keyed, so it goes in one way. Whereas on the British unit, it uses that shielding for the key. This is a 1957 American unit. It's got a lot of tubes in it. This is it does FM too. It's just another one of my projects, but this guy does a lot of frequencies that one doesn't. These tuning cans. I hope somebody wasn't in there with the screwdriver adjusting. I'm trying to get this thing to work. It was pretty dead because that power resistor was gone. Alright, I'm gonna need to replace all the paper caps. There's no volume. There's no volume at all on that. There's no increase of volume, so we know that cap is bad, and I might as well just do them all while I'm in there. It's gonna be a while. Get that done. And I want to test the tubes too. I want to see if there's anything wrong with these, because we know it was overheated. It blew that power resistor, and that can't be good. But we know both transformers are good. The power transformer and the audio transformer. If this isn't more easy to get working after those two procedures, then what we're going to have to start doing is tracing the sound, the IF frequencies, like to the cans, and then the audio section. And I got the manual for this, so there's a lot of voltage points that you do to test to make sure it's running correctly, and then we'll run the procedure for tuning it once we're all done, and get this thing receiving like it should, like it did originally. Very cool. I'll do another part 2 on this when I have the time, and I will update you. Thank you for watching. Got all the paper caps replaced with the polyesters. Lasts a lot longer. Trawler band's pretty interesting. It's 1 megahertz thereabouts. I don't know how wide it is. I need to figure that out a little bit better. It seems like that overlaps a little bit of our AM broadcast bands. Getting into shortwave. Shortwave is just a bunch of religious programs. A lot of them from the South. Some stations are more powerful than others. This is a pretty solid unit. I really need to test the tubes, see what's...
So now Jesus is drawing this dividing line between these two. So...
See, they're pretty old. I mean, it's going to be unknown performance characteristics until I can figure out how to test them better.
Lindgren kicks the puck ahead for Carrick, and he sends to center. This is Mike Krauser, heard worldwide in 173 countries in all 50 states.
So it's working. It's this is medium wave AM broadcast band. It kind of blows out with the sound. I don't know what that's all about. I'm gonna have to do some more tweaking and testing. I can't test the tubes. my tube tester doesn't cover the British tubes, so I'm gonna have to figure out how to test those a little bit better. Probably get some voltage and hook it up to the scope, see what we can get for waveforms and stuff. I don't know. Be nice to be able to test them. I'm gonna look into the specs on that stuff. Medium wave's alright. I mean, there's really nothing there to listen to anyway. It's just sports and more sports. But it's working, and we're gonna be able to fine tune this a little bit better and
championship for this
check out the other bands.
Fun for you back here. That's pretty cool.
That's amazing, man. I'm so happy.
Thank you, Green.
All right, Olivia. Thank you very much.
Pretty cool. WWV time signal from Colorado. Barely receiving it. Shortwave. Good sound on the radio though. It really is a good quality sound. I really need to get a wire outside. Try to pick this up better.
This is WTEV, Channel 6 in New Bedford, Massachusetts, bringing to a close its telecasting for the day. WTEV is owned and operated by WTEV Television Incorporated and is affiliated with the ABC Television Network. WTEV studios are located at County and Spring Streets in New Bedford. Our transmitter is located in Tiverton, Rhode Island. WTEV operates on Channel 6 with a video output of 79,500 watts and an audio output of 39,750 watts by authority of the Federal Communications Commission. Certain programs seen on WTEV during the telecast day were on film, pre-recorded, or delayed network television programs. Until we return to the air this morning, this is Andy Macmillan wishing you a very pleasant good night. And now, our national anthem.